So let's talk about questions 3 and 4. Questions 3 and 4 use the same circuit. So actually questions 4 relies on the answers of question 3 to be able to do it. Let's move forward. Actually, before we do, I just wanted to mention one thing. To calculate the current going through here, I have two options. One, I can use this formula, which is power, resistance, and current, P equals I squared R. Or I can just use P equals V times I. I know the power because it's actually written here, and I know the voltage, so I can easily calculate the current. But I want to use this formula because I'm showing you how to use the square root function. So that's why I'm asking you guys to solve this with this. Again, you're going to use these values and you're going to get these values in your answer, but I'm using, for my power, I'm using 410 milliwatts, and for my voltage, I'm using 11.3. You guys are using 130 milliwatts, and your voltage is 6.32. Good. So the one thing I wanted to mention before I actually show you how to do the math on your calculator is the fact that you're going to do this step. This is going to be in your calculator, and then you're just going to use that calculation in here. But the thing is, when you do that in here, you're going to have to put your value in memory to get it in here, or you're going to have to use the answer function on your calculator. I'll show you how to do both on my calculator, but this is not as easy as our first one up here that we did, this guy, because our values, this answer went straight into here, and then I got my second answer. So I didn't have to use memory or anything. I just kept the value in my calculator. But down here, what we're going to need to do is we're going to need to use the memory. We're going to have to put this value in memory. So when I put it in here in this formula, I'm keeping all of the decimals. Now, I also wanted to note before I do the math on the calculator this. I've got this value that I've calculated, but I'm writing down 311.44 in my actual formula. It's understood that if I'm getting this value from this calculation, then I'm using this exact value from memory and I'm putting it into here. So I hope that makes sense. Okay, let's move forward and take a look at how to do this on your calculator and how to actually get this out of your memory and put it here. There are two ways to do this. They're a little tricky, but I'm going to show you, and I think you will be empowered by this. So let's jump to the calculator. All right, let's take a look at my calculator, how I can take this calculated resistive value that's got this crazy floating point decimal and put all of its value into the denominator of this. We can't just keep it in my calculator and then, do some stuff here. I've got to somehow put this in memory and then stick that and recall the memory and put it in there. Let's actually see how that works. First of all, I need that number, so I have to calculate my power. So, my resistance. So I'm going to calculate that by 11.3 squared. Everybody's got one of these on their calculator, squared. And I'm going to divide it by 420 milliwatts, divided by 410 milliwatts. Now that's milli, so I'm going to do minus 3. There you go. So that's the number. I'm going to put it into storage in my calculator. And what I do here, it's really cool. I just hit storage, and then I hit this, and I pull up one of the letters. I've actually got 27 characters where I can store values. I hit enter. Now, if I recall that and I hit enter, I'm going to get the same value. Now, I can also store that on this calculator into any one of these letters over here that are in green. So I'm going to do second function alpha Z. So I've just stored it in Z. And if I recall Z, it's going to have that. So I can either put Z in my formula or X. Now, moving forward, I'm actually going to calculate the current. So I'm going to find the square root. Now in here, I've got 410 milliwatts. So 410 milliwatts. And that's going to be divided by my answer. So I'm just going to recall my X here and I'm going to hit enter. There you go. So that's the answer, is 36.28 milliamps. Now, I did say there's another way to do that. I'm going to go back and I'm just going to pull up, actually I don't need to pull up this value. I don't need to do that. I'll show you how you can do this without memory. And this is kind of a little bit backwards, but it still works. And I think it's important that you stick around and just wait for this, because it's a really cool thing you can use in a lot of formulations, and it saves you having to use memory. So I'm going to recalculate the power. 11.3 squared divided by 410 milliamps. I've got this in my calculator. Now the thing is, if we take a look at this, I have to divide this by that. So if I were to actually, because it's in my calculator anyway, if I were to take this and then divide it by this, I'd actually get the inverse of what I'm looking for. Well, I've got an inverse key, and I can find the inverse of the inverse is actually That's the answer. So I'm going to take that and I'm going to divide it by 410 milliwatts. And that's not the answer. That's the inverse of the answer. So I'm just going to hit my inverse key, and that is actually the answer. But now I've got to find the square root of that. So I've got a couple different options. Again, I could just use memory. I could put that in memory and then recall the memory and find the square root of it. Or on my calculator, I've got this answer function. So I can do second function square root and then second function answer, and I can hit enter and I get the same value. So now you know two different ways to do this. Now that second step that I just showed you is good for a situation where the second calculation, you've calculated a value, and in the second step of that calculation, you've got to stick it in the denominator. You can just actually divide it by the numerator and then hit inverse. I think moving forward, it's just a matter of practice. Get to know how to use your calculator. Be friends with it. You're going to be using it a lot.